The goal of today's lesson is to identify different types of solutions to systems of equations. One of the different situations we're going to be talking about today is when there's one solution. And that one solution to a system, remember, is a point on a graph where those two things intersect. No solution is when you have a set of parallel lines that will never intersect, so therefore they don't have a solution. The last case that we're going to talk about is infinitely many solutions. Infinitely many solutions means that the two lines that you are given are actually different representations of the same line, so therefore they share all of the points on that line. This will be learning goal SE2 SE3 standing for Systems of Equations Learning Goal 3. One fact that we talked about in the last lesson was that two lines that have the same slope and a different y-intercept will be parallel. Notice how this system of equations has a slope of 2, but the two lines have different y-intercepts. So these two lines will be parallel. They can't have the same y-intercept and the same slope because then the two of these lines would be the exact same line and they would not be parallel. Look at your classwork and I'm going to read the launch with you. Imagine you are growing two basil plants in the same garden with the same conditions. One seedling started out at 6 centimeters tall when you planted it, and the other was 4 centimeters tall. If the conditions allow the plants to grow at the same average rate of change, what can you say about the functions, and what can you say about the plants based on your knowledge of linear functions? Please pause the video to answer this question. Then once you're ready to check back in, please push play to continue. A good response to this situation would be something that is similar to what I have. I said that the same rate of change means that these two functions will have the same slope, and this tells us that the lines will be parallel, so they do not have a solution. For the plants, what this means in the context of this question is that it means that the plants will never be the same height, because if the two lines will never intersect, then that means the height of the two plants will never be at the same height in centimeters. Moving on to the first example on our classwork, you'll notice that you see this little bracket in front of your system of equations. This bracket just indicates that this is a system of equations, so it shows that there should be some sort of a connection between the two lines that we are going to graph. So please pause the video and either use your calculator or use your knowledge of slope and y-intercepts to graph the following function. Once you have the system of equations graphed on your calculator, on your paper, please play the video so that you can check to make sure that you've graphed this system properly. Now that you've graphed these two linear functions, please make sure that you've graphed them correctly. Also make sure that each of them have a label and the label is indicated next to the specific function you're referring to. Notice how both of my lines go all the way through the graph, and on all ends of my lines I have arrows. This case would be a situation where we have one solution. The one solution is where these two lines intersect. So this is a case where we have a set of intersecting lines, and the solution point on this graph would be at -3, -1. So -3, -1 is my solution. Now please pause the video and graph the next system of equations. Once you have graphed both of those functions, please push play to check your system. Here's the graph for the second system of equations. Notice how these two lines are parallel. You should have also been able to see that they have the same slope, which would mean that these two functions, because they have different y-intercepts, will end up being parallel. Notice how my lines are color-coded, but just to be safe, to make sure that my labels are matched with my graphs, I'm going to make sure that I label each graph using the letter that I've indicated above. So now that I've done that, I'm going to identify this as a set of parallel lines. And in this case, my solution will end up being no solution. And remember, it's no solution because there is no point of intersection between these two lines. Please pause the video, graph the next system of equations. Notice how these are not in slope-intercept form, so you'll need to transfer them into slope-intercept form so that you have y equals mx plus b, or you get y by itself. Please make sure to do that before you graph these functions. Once you've done that, please push play to check your solutions or to check your graph. Here is the graph of the third and final system of equations. It might be hard to see, but you should notice that the two lines that you graphed will go right on top of each other because in fact they are the same line, even though they didn't look like it until you put them into slope-intercept form. This is what we call a set of coinciding lines because it's kind of like they coexist at the same time. So in this case, there isn't no solution, there isn't one solution, because all of the points match for both lines. We say that this is a infinitely many solutions situation. So it would have infinitely many solutions. These are the three different cases for solutions to systems of equations. Now that we've just gone through all three different situations, let's summarize. Remember, one solution is where the 2 points meet at a point on the graph. Infinitely many solutions is where there are two lines that end up being at the same position or on all of the same points, and this is where they are the same equation. The third situation we just talked about is when there's no solution, and this is when you have a set of parallel lines, and you have a set of parallel lines when the two lines have the same slope, but they have different y-intercepts. Please finish the rest of the classwork using this information. If you need help, please feel free to ask your sub or ask your classmates.